Welcome to the introduction to our project iWaGSS. The results presented are based on several studies, field surveys, and pilot implementation in a South African catchment by a large number of both German and South African and African project partners. The region, as many others worldwide, is facing several challenges like water quality and quantity issues, impacts of climate change, which are subsumed under the topic water resources management, as well as challenges, institutional challenges that deal with water sector governance. And here we are dealing with conflicts between the rules in use, the rules in form of legislation and institutional frameworks, and the rules in use on local water management level and operational level. So this is called the implementation gap between macro and micro level governance. And both these water resources management challenges and the water sector governance challenges result in water crisis, deterioration of resources, collapsing infrastructure, and substandard water services. The main goal of the iWaGSS project was to provide data and information to improve water resources management by all relevant actors and stakeholders, both those actors legally responsible for water management and informal actors taking over water management functions. The iWaGSS water management system consists of different tools and methods like risk assessment, surface modeling, and so on, which will be briefly presented in the following slides. We are starting with contamination risk assessment. These are tools that identify contamination risk based on groundwater, erosive runoff, and direct discharge into water bodies. And this is based on resources sensibility and contamination potential. And the evaluation of these risks identifies priority areas and subcatchments with increased problem intensity and need for action. Surface water modeling is an additional input to the system, which contains both modeling of the river network, including discharge, water levels, flow rates, and so on, and reservoir modeling, which contains sedimentation, remobilization of sediments, and also improved operational rules for reservoirs to both guarantee for the supply of drinking and bulk water for industry and also avoid ecological damage in downstream areas. Then we've got a real-time water quality monitoring network, which is linked to the system, and several parameters like toxicity, pH, conductivity, and so on are monitored. And by combining these monitoring data with the flow conditions from the modeling or the risk assessment, it is possible to predict the distribution of pollutants or to track back possible sources of pollution. This data is also accessible on a smartphone app to directly get access to the real-time quality data for all the interested partners. In addition, a multi-parameter drone has been developed and tested to collect remote sensing data like aerial pictures, digital surface models, river cross sections or vegetation indices, which was also an input to the water management system. The user can access this real-time water management system via a GIS portal where the data is processed and provided. This water management system has been presented 2 days ago in a side event, and I think the video is available on the GRoW marketplace now. You can choose and select relevant data and layers, can export data into shapefiles or Excel data sheets, or generate reports on several quaternary catchments of the catchment. And the real-time water management system has different access levels, both for experts and water managers, and for information of the public. This is due to the fact that several of these information requires a certain background of information. For example, if you see a red risk area in the system, it's just a risk of contamination, and if you publicly spread the information, this is a red area, you might cause some troubles with information. So there are different access levels to these tools for different user groups. This water management system is accompanied by several socio-economic studies on incentive mechanisms. Yesterday you heard about the 7 sins on local water management. We've got studies on ecosystem goods and services and the provision of ecosystem services in the river system. We've got financial concepts for infrastructure investment and the operation and maintenance of water infrastructure and services to improve the resources management and the sector governance. This also includes transboundary water governance mechanisms to overcome mistrust among stakeholders, to counterbalance local power asymmetries, and to generally foster the cooperation of the partners involved. All these methods and tools have been developed to improve water sector governance in the absence of failure of established institutional structures. We heard this morning in the presentation of Professor Paul Vostel that South Africa has a really worldwide acknowledged body of water legislation, but they are struggling with the implementation on local level. And we found out that it's very important to improve the information and the availability of data for the people locally doing the water management. And these are not necessarily the legal institutions. These are also informal actors taking over water management functions just to keep the river flowing or to keep a certain level of environmental requirements or to distribute the water to different users. And all these partners or actors and stakeholders need reliable and transparent information provided by the system. And the two main results are that easily accessible and reliable data and information is key for effective resources management, and that financial and economic aspects have to be taken into account in water management. And so this allows for good water governance, which is key for efficient resources management. We've got further information on the project and results with several videos, presentation, and so on the virtual marketplace, on our project website, and we have a special issue on iWaGSS here in Korrespondenz Wasserwirtschaft in the recent publication this month, which is also available. And coming to the end of this presentation, we have to thank, and I want to thank all the partners, BMBF for funding the project, the GRoW activities, all the German and South African institutions, and all the people, especially the people involved who made this possible. So thank you very much for the contribution to the project and for listening to this presentation. Thank you.